Hello! Today we are going to be performing extremely interesting operation of making this vintage Zero Yeti 400 great again and ready for year 2025. And that's because we are going to be replacing the built-in lead acid battery with lithium iron phosphate. Price and difference between lithium iron phosphate is going to be minimal, but the benefit of the lithium iron phosphate is just crazy. You will get like over 4,000 cycle without any problem. I still own old, over 10-year-old Victron Energy lithium iron phosphate, the old generation, the massive one that is like twice size what they currently manufacture, and it is still working great. It holds capacity, and the internal series resistance is so low that I've got no problem pulling like 100 amp from it. So in my personal opinion, they will die from aging, not from cycling. And for that use case on that Goal Zero, I'm pretty sure that lithium iron phosphate battery is going to be the last that I will ever replace. And after like 10 years or 15, most likely there will be a better chemistry and this device is going to be still working great. That's my assumption, and we will see it. We need to discuss just one thing, and that's because the Goal Zero Yeti 400 is recharging the lead acid battery with a float charging voltage, so we are around 14 volt, 13.8 volt. And if that's going to be enough for fully recharge your battery, and the answer is most likely yes, you are going to be getting almost full capacity. They, from technical point of view, do not need to be fully charged, but there is one thing that someone could argue, and if you are not top charging them to 14.4 volt, then you could technically risking situation that the BMS is not going to be balancing cells properly. So yes, I give that this could be thing. So maybe one time in year, maybe two, we've got access to the side port, and one time per year, maybe 2 years, we can attach here lab power supply and apply 14.4 volt for like a couple days to make sure the battery is going to be fully balanced. But I do not predict that is going to be an issue, but we will see. But what we are going to be doing during this video is that we will swap it for the lithium iron phosphate, and afterward I will fully recharge it using our solar input, then discharge it using my lab charger, and we are going to be seeing the capacity. So first, let's take a look what kind of battery I purchased. And I've got this beauty. It is extremely lightweight. I can basically lift it by one finger. And it is 33 amp hours, so we should get like a similar capacity. What we can learn from our technical specification that is available here. First of all, our discharge voltage is 10.8 volts, so we are fitting perfectly characteristic of a regular lead acid battery. Then we've got the maximal current for the BMS of 30 amp, and if we multiply our 30 amp with a 12 volt, then we are getting over 300 watt, and our inverter is 300 watt, so this should be absolutely not issue, and we should get a perfect fit. Just take a look how beautiful it's going to be presenting. Let's begin our operation. And we are ready to lift it up. And we are going to be learning, did I purchase correct size? And looks like we are getting exactly the same dimensions. And I think we are going to be getting a great success. Let's start from removing our metal bracket. Here is our bracket remove. And now we can undo our terminal. So we go like this. Then we go with our positive. Then we remove our battery, and yes, it's going to be heavy. Yeah, that was horrible. Yeah, we've got a perfect match. Just take a look. And we are lifting it like it. Absolutely crazy. Here we've got something very interesting that I never seen in my entire life. Because the manufacturer give us actually a terminal post that is insulated. Absolutely beautiful. I never seen it in my entire life. This is a real beauty. It is so beautiful that I would like to use it, but I'm a little bit afraid, are we going to be getting enough room? So I'm not sure. It is so beautiful, but I think we are constrained with our size. So let's go with something that we have. Okay. Then we go with our negative. Just like that. Absolutely beautiful. I love this design. That is really amazing. We can get spark, so do not be worried. Things like this can happen. Perfect. It's looking great. So easy to work with. This is amazing. This is exactly what I wanted. That is going to be the most beautiful upgrade I ever done in my entire life. Such a huge improvement in form of usability. Okay. We go here. Okay. Perfect. It won't be rattling around. This got a very nice, like a pillow. So yes, we can close it down. I'm looking here and maybe we had enough room for those posts, but let's keep it like the Goal Zero did. Let's pretend they had a ride. So we go like this. So this is what we end up with. Let's try to power it on. And as you can see, we've got our output power. We've got the full capacity indicator. Let's check the volts. And yes, indeed, we are fully charged. Let's go to watts and let's try the inverter. Maybe this device for sterilizing medical instruments. So we go here, we start the inverter, and we are pulling 140 watts, and everything is working fine, and we are warming up, so this worked perfect. We can load it with something else. Let's try load it with more power. And currently we are on 200 watts. And everything is working fine. So I'm 100% sure that our inverter is going to be working great and even better because the voltage drop is going to be much lower. Let's test it with this tiny kettle. We go like this, we're starting the power output, we're starting heating, and we are pulling 260 watts. The PWM is most likely modulating it. But yeah, you can clearly see that everything is working fine. This is exactly what we wanted to see. Here is our test setup. Over there is my lab power supply. I'm providing 20 volts with a 3 amp current limit to our solar input, and the PWM charger is recharging our battery. And as you can see, we are pushing 40 watts. As you can see on the display, we've got information that our charging process is completed. We've got inputting 0 watts through our solar port, and on the power supply we are also reading 0 amps. So what we are going to be doing right now, first I will attach our side port into my charger that you can see on the rear. Here we can see our Anderson power pole connectors that are directly connected to battery terminals and are bypassing any electronics. And I will plug myself here. And we are going to be connecting to our negative terminal and to our positive. It would be smart to not create a short. Let's together take a look at my computer and configure our charger. First, we are going to be selecting lithium iron phosphate chemistry. We are selecting 4 cells. Then we are inputting 33 amp hour capacity. We are interested in discharge test with the maximum possible current that this charger can support. And we are going to be beginning our operation, and this process will definitely take like more than 10 hours. So yeah, we are going to be speeding that up. And let's go to the channel 1. And here we are going to be seeing our beautiful graph. So let's give it a moment. And as you can see, we are getting information about the current. We've got 2 amp. And we are getting closer to the target. And I will leave it as is. And we are going to be see what kind of capacity can we get. So as you can see, our discharging process is completed, and we measure 37 amp hour, which is higher than the stated value, but most likely that's because we were using pretty low discharge current. This is the highest that the device that I'm using allow. So based on that, I can tell you that we've got absolutely no problem recharging our lithium iron phosphate battery through the solar input. We've got a good capacity. As you were able to clearly see, operation of replacing our seal lead acid battery with lithium iron phosphate work like charm, and in my personal opinion, we've got absolutely no issue with using our solar input and recharging it through the Goal Zero built-in controller. And just like I told you, there is technical possibility that once for a year or more, we could use our side port and dedicated charger to make sure our balancing circuit is going to be activated. Beside of that, the capacity loss basically do not exist. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.